Hello viewers, in today's session we are going to discuss another important conceptual problem from three-dimensional geometry, and here we are going to take up this problem from the topic that is intersection of planes, right? So here we have to find the equation of the planes passing through the line of intersection of the planes, having equations x plus 2y plus 3z minus 5 is equal to 0, and 3x minus 2y minus z plus 1 is equal to 0, and cutting off equal intercepts on the x and z axis, right? So here we are given the equations of two planes, and we have to find out the equation of the planes passing through the line of intersection of these two planes and cutting off equal intercepts on the x and z axis. So here we'll solve this problem using the concept of intercept form of the equation of a plane. So let us start. So now let us denote this plane by P1 and this plane by P2, right? So let us draw a rough diagram here. Suppose this is our plane P1, and this is our plane P2, right? And we have to find out the equation of the plane which passes through the line of intersection of these two planes P1 and P2, right? So here the plane which passes through the line of intersection of these two planes is this line, and here we have the plane, the required plane, and let us call this plane as P, right? So P passes through the line of intersection of planes P1 and P2, and always remember whenever two lines intersect, then the lines intersect at a point, right? But when two planes intersect, they always intersect in a line, right? So the equation of the plane P which passes through the line of intersection of plane P1 and P2 is given by P1 plus lambda P2 is equal to 0. So this is the equation of plane P which passes through the intersection of these two planes P1 and P2 for some value of lambda, and here lambda is a scalar, and we'll find out the value of this lambda by using this condition which is given as cutting off equal intercepts on the x and z axis. So let us substitute the value of P1. So the plane P1 is x plus 2y plus 3z minus 5, and then we have lambda times 3x minus 2y minus z plus 1 is equal to 0. So let us rearrange this equation. So we have x plus 3 lambda x, and then we have 2y minus 2 lambda y, and then we have here 3z, and then we have minus lambda z, and then we have minus 5 plus lambda is equal to 0, right? So here we can take x common, so we have 1 plus 3 lambda, then we have here y common, so we have 2 minus 2 lambda, then here we have z common, and we have 3 minus lambda, and let us take this term to this side. So we have here 5 minus lambda, right? Now let us divide both sides by 5 minus lambda, because we have to convert this equation into the intercept form of the plane, right? So we have x, then we have 1 plus 3 lambda over 5 minus lambda, y2 minus 2 lambda over 5 minus lambda, and then we have z 3 minus lambda over 5 minus lambda, and here we have 1, right? And obviously here we can also write this equation as here we can write 5 minus lambda over 1 plus 3 lambda, right? So taking this term, that is 1 plus 3 lambda, to the denominator of 5 minus lambda, and similarly here we can write y over 5 minus lambda over 2 minus 2 lambda, and then we have here z over 5 minus lambda over 3 minus lambda, and this is equal to 1, right? So what we have done here, we have written the equation of the plane P, which is given by P1 plus lambda P2 is equal to 0. Substituting the value of P1 and P2 in this equation, we have arrived at this equation. So the purpose of writing this equation is that we know that the intercept form of the equation of a plane is x over a plus y over b plus z over c is equal to 1, right? So this equation represents the equation of a plane which cuts the intercept a, b and c on the axis, that is x, y and z axis. So a is the length of the intercept cut by the plane on x-axis, b is the length of the intercept cut by the plane on y-axis, and c is the length of the intercept cut by this plane on z-axis. So now the equation of the plane P in this form, that is the intercept form, is given by this equation, right? So that's why we have written 1 plus 3 lambda in the denominator of 5 minus lambda, and similarly 2 minus 2 lambda in the denominator of 5 minus lambda, and 3 minus lambda in the denominator of 5 minus lambda. So the length of the intercept cut by this plane P on the three axes, that is x-axis, y-axis and z-axis, are given by comparing these two equations. So the value of A is 5 minus lambda over 1 plus 3 lambda. B is 5 minus lambda over 2 minus 2 lambda, and C is 5 minus lambda over 3 minus lambda, right? So now in the given problem, we are given that the equation of the plane passing through the line of intersection of these two planes and cutting off equal intercepts on the x-axis and z-axis, right? So A is the length of the intercept cut by this plane P on x-axis, and the length of the intercept cut by this plane P on z-axis is given by C. So here we are given that A is equal to C. So the length of these two intercepts are equal, because here we are given that cutting off equal intercepts on the x and z axis. So we can now equate these two terms, that is 5 minus lambda over 1 plus 3 lambda is equal to 5 minus lambda over 3 minus lambda. So now let us solve this equation, right? So taking the cross multiplication here, we have 5 minus lambda, 3 minus lambda, and then we have 5 minus lambda, and here we have 1 plus 3 lambda. So taking this term to this side, we have 5 minus lambda, 3 minus lambda minus 5 minus lambda, and here we have 1 plus 3 lambda is equal to 0, right? Now taking 5 minus lambda common, so we have 5 minus lambda, and here we have 3 minus lambda minus 1 plus 3 lambda, and this is equal to 0. So we can solve it. 5 minus lambda, here we have 3 minus lambda minus 1 minus 3 lambda is equal to 0. So this is 5 minus lambda, and here 3 minus 1 is 2, and here we have 4 lambda, right? So now this is the product of two linear factors in lambda. So we can have 5 minus lambda is equal to 0, and from here we have 2 minus 4 lambda is equal to 0. So from here we have lambda is equal to 5, and from here we have 2 is equal to 4 lambda, and lambda is equal to 2 over 4, that is half, right? So we have obtained two values of lambda, that is 5 and 1 over 2. So now to obtain the equation of the planes, we have to substitute the values of lambda in this equation, right? That is p1 plus lambda p2 is equal to 0. So here we can take this equation as equation number 1. So let us first take lambda is equal to 5. So we have x plus 2y plus 3z minus 5, and then we have 5 and 3x minus 2y minus z plus 1 is equal to 0. So simplifying it, we have x plus 2y plus 3z minus 5, and this is 15, and then we have 10y, and then we have 5z, and here we have 5, right? So 15x plus x is 16x, then we have 2y minus 10y is minus 8y, 3z minus 5z is minus 2z, minus 5 and 5 get cancelled, right? So let us divide throughout by 2. So we have here 8x, then we have here y, and here dividing both sides by 2, here we have 4, and then here we have z, and this is equal to 0. So this is the first equation of the plane passing through the line of intersection of these two planes and cutting off equal intercepts on the x and z axis. Now let us substitute lambda is equal to half in this equation number 1. So now we have x plus 2y plus 3z minus 5, and lambda is half, and we have 3x minus 2y minus z plus 1 is equal to 0. So now multiplying throughout by 2, we can now write here 2, then we have x plus 2y plus 3z minus 5 plus 3x minus 2y minus z plus 1 is equal to 0. So we can now write 2x plus 4y plus 6z minus 10, and this is 3x minus 2y minus z plus 1 is equal to 0. So now 2x plus 3x is 5x, then 4y minus 2y is plus 2y, and 6z minus z is plus 5z, and minus 10 plus 1 is minus 9, and this is equal to 0. So this is the equation of the second plane which passes through the line of intersection of these two planes and cutting off equal intercept on the x and z axis. So here we have two equations of the planes. It means there are two planes which passes through the line of intersection of these two planes, that is p1 and p2, and cutting off equal intercept on the x and z axis. So this equation corresponds to lambda is equal to 5, and this equation corresponds to lambda is equal to half. So here the two planes are given by these two equations, right? So let us first convert this equation into the intercept form, right? So we can write here 5x, then we have plus 2y plus 5z is equal to 9. So taking this negative 9 to the right hand side, and let us divide both sides by 9. So we have 5x over 9, then we have 2y over 9, and then we have 5z over 9 is equal to 1. So we can also write this equation in this form as x over 9 by 5, then we have y over 9 by 2, and then we have z over 9 by 5 is equal to 1. So if we compare this equation with this one, then the value of the x-intercept is a is equal to 9 over 5, b is 9 over 2, and c is 9 over 5. So the values of x-intercept and z-intercept both are equal, that is 9 over 5 and 9 over 5. So now let us look at this plane. So here we have 8x minus 4y minus z is equal to 0, right? So now if we closely observe this equation of the plane, then we can see that this plane passes through the origin, right? That is 0 comma 0 comma 0, because the coordinates of the origin satisfies this equation, because here we have 8 times 0, 4 times 0 minus 0 is equal to 0, right? So this plane passes through the origin, right?